Okay, all right, let's go ahead and finish this up. We got question number 32. It says use this formula to determine the regular payment amount, round it to the nearest dollar. So your credit card has a balance of 3,000, an annual interest of, no, let's change this. An annual interest of 14%, and you decide to pay it off in 4 years. Okay, so we have payment is equal to the amount owed is 3,000. The interest is 0.14, making monthly payments. And then here we have 1 minus 1 plus 0.14 divided by 12 raised to the negative 12, and you want to do it in 4 years. Okay, so times 4. And so the payment is equal to, again, we are making, we're taking advantage of the calculator. So here I am using the calculator. Hopefully you pause the video and you use that as well. And it turns out that the monthly payment is going to be $82. Rounding it to the nearest dollar is 82. Again, I'll leave it up to you to go through these computations using your own calculator. So what is the total interest paid over 4 years? Again, this particular person was making a payment of $82 every month for 4 years. That turns out to be equal to 3,936. So therefore, the total interest is 3,000 minus the total pay minus the 3,000. So therefore, the interest that was paid is what, $936. Okay, moving on to number 33. I think we're jumping into a different chapter now. It says license plates in a particular state display 2 letters followed by 4 numbers. How many by 4 numbers? How many different license plates can be manufactured for this particular state? So there's 26 letters in the alphabet, and it didn't say anything about repeating. So therefore, any of the 26 letters on the alphabet. How many different license plates? How many numbers? Okay, so we could choose 0 through 9. That will be 10. 10, 10, 10. Okay, so therefore we have 26 raised to the second power times 10 raised to the 4th power. 26 squared times 10 raised to the 4th power, and we have, in this case, 6,760,000 different license plates. Okay. A camp counselor and 4 campers are to be seated along a picnic bench. In how many ways can this be done? If the counselor must be seated in the 4th seat, and a camper who has a tendency to engage in food fights must sit to the counselor's immediate left. Okay, so a counselor and 4 campers. So that's 5 people. The counselor must sit here, and the person that begins the food fights must be on immediate left. So I'm going to put here. And so therefore, that leaves 1, 2, 3 different chairs. Okay, and so therefore there are now 3 available campers. And once the first person sits here, then the other 2 are available. And once the first 2 are seated, that leaves with 1 person to take the very last chair. So that is 3 times 2 times 1, which is equal to 6. So that can be done in 6 ways, because this person must sit here. To the left of the counselor, we must have this immediate person. That leaves 3 students to take this spot. Once the first person takes this spot, that leaves only 2 available for this spot. And then once these 2 are taken, that leaves only the 1 person available for this spot. We want to use the permutation formula. So we have 14 permutations taken 0 at a time. So we have 14 factorial divided by 14 minus 0 factorial. This is 14 factorial over 14 factorial. This is just equal to 1 because these 2 quantities will just cancel each other out. Okay. 36. A club with 9 members is to choose 3 officers: president, vice president, and secretary treasurer. So 3 officers. If each office is to be held by 1 person and no person can hold more than 1 office, in how many ways can this be done? So we have the president, we have the vice president, and we have the secretary treasurer. There's 9 members available, so any of the 9 members can be president. But once a president has been selected, only 8 are available for vice president. And once a vice president and a president has been selected, that leaves only 7 people available for the secretary treasurer position. So we multiply 9 times 8 times 7, and we get 504. So this can be done in 504 ways. Okay. Alrighty then, let's see. Use the formula to evaluate the number of combinations here. So, the number of combinations of 22 objects taken 3 at a time is 22 factorial divided by 3 factorial. 22 minus 3 factorial. That's equal to 22 factorial over 3 factorial times 19 factorial. And after using the calculator, that will be equal to 1,540 ways. Okay. Number 38. Of the 16 books possible, you plan to take 4 on vacation. How many collection of 4 books can you take? Okay, so this will be a combination problem. So in this case, you have 16 books available. You're trying to find the number of combinations if you take 4 objects at a time. And in this particular case, I just want to do this with the calculator. 16, math, go to the probability menu, 3, then I put a 4 here. Again, we already wrote the definition down earlier, so I'm okay with just getting the right answer here. And it's just 1820. Again, the reason why I didn't write it all out is because we had already done that for 2 previous examples, and I figured I just wanted to get the right answer and show you how to use the calculator as well. 39. You are dealt 1 card from a 52 card deck. Find the probability of being dealt a heart. There are 13 hearts in a standard deck of cards. So therefore, the probability of being dealt a heart is equal to 13 over 52, which is 1 over 4. Number 40. Use the spinner shown to answer the question. If the spinner is spun once, find the probability that the pointer lands on a region that is brown or is blue. That will be, well, in this particular case, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 regions in total. How many of them are blue, are brown, or blue? Well, I guess I can count again. 1, 2, 3. How many of them are blue? 1, 2. So that will be 5/10, or just 1/2. Okay. Moving forward, number 41. Kim, Ian, Larry, Maria, Eduardo, Jim, Tyrone, and Katrina have all been invited to a dinner party. They arrive randomly, and each person arrives at a different time. And how many times can they, in how many ways can they arrive? Well, in this case, we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8. Okay. So they arrive at different times. So any of the 8 could arrive first. But then once the first person arrived, then that leaves 7 available for second place, then 6, then 5, then 4, then 3, then 2, then 1. This is equal to 8 factorial. Okay. So I'm just putting the multiplication symbols here. Okay, so a factorial, 8, math, probability, option 4. That is 40,320. 40,320. In how many ways can Kim arrive first, Kim, and Katrina last? So 1, 2, 3, 4, 5, 6. That will be, so if this is the arrangement, then Kim must be first, Kat must be last. That leaves 6 other people to show up second, 5, 4, 3, 2, 1, or 6 factorial. That is equal to 720. Find the probability that Kim will arrive first and Katrina last. Okay, so Kim, the probability that Kim is first, Katrina last, that's equal to, well, 8 factorial ways for 8 people to show up to a party, 6 factorial ways for this arrangement to happen. And so therefore, using the calculator, 6 factorial divided by 8 factorial. And then we could press math, enter, enter. 1 out of 56. So the probability is 1 over 56. All right, moving forward to number 42. The STEM and Neve Flood compared the ages of 30 actors and actresses at the time they won. What is the age of the youngest actor to win the award? Okay, so this represents the ages 20, 21, 24, 26, 26, and 27. So here we can clearly see that the youngest age is 20. This age right here will be 78, just to kind of give you some example on the actor's side. All right, so what is the age difference between the oldest and the youngest actress to win the award? Well, the oldest actress is 82. The youngest is 20. That's a difference of 62. What is the oldest age share by 2 actors to win an award? And so there are, okay, so that is 32, 32, but that's not the oldest because we got 40, 48, 48, 58, 58, and that's, okay, so that will be 58 years old. Okay. All right, and then part D, what difference do you observe between the 2 stem and leaf plots? What explanations can you offer for these differences? And so in In this particular case, the answer will be C. There is a higher frequency of actors in their 40s and 50s than actresses, and a lower frequency of actors in their 20s. And I think that we're missing a piece of something missing here. I'm not really sure what, but the answer there is C. I think I'm more concerned with part A, B, and C than I am with D. Okay. All right. Use the data to find the mean, median, mode, and mid-range. Okay. So according to here, there are 2 10s. There are 2 10s. There are 2 11s. There are 5 12s. There's only 1 14. There are 2 15s, and that's it. Okay, so we have, I should have just written this on the side here. 10, 10, 11, 11, 12, 12, 12, 12, 12. I think I forgot to write there are 6 13s. Okay. I don't know why I'm doing this like this, but I already started, so I'm already committed. Okay, and then we have 1 14 and 2 15s. Okay. So the mean will be the sum of these numbers, or better yet, 2 times 10 plus 2 times 11 plus 5 times 12 plus 6 times 13 plus 1 times 14 plus 2 times 15. All of that. So the mean is equal to all of that divided by 2, 4, 9, 15, 16, 18. There are 18 data items. 2, 4, 9, 15, 16, 18. So now let's go ahead and use the calculator to find this sum and then divide it by 18. And we get that the mean is equal to 12.4. The median, okay, the median is the is the value in the middle. So we have 18. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So the 9th and the 10th place. Okay, we'll take the average. Okay, because there's really not one in the middle. There's 2 in the middle. So to find the median, we'll do 12 plus 13 divided by 2, and that will be 12.5. Notice that the median and the mean are relatively close. The mode is the most repeating data item, and the data mode is 13. And the mid-range, okay, that is going to be 15 minus 10. Okay. Oh, what we got here? Okay, so we have 15 plus 10 divided by 2, so we get 25 divided by 2, which is 12.5. Okay. Find the standard deviation. Okay, I think I'm just going to use the calculator for this. So let's look at those numbers. And so it seems like we got 1, 2, 3, 4 13s. And we have 1, 2, 3, 4 17s. So I'm going to go to my calculator, press stat, edit, and we got 1, 2, 3, 1, 2, 3, 4. We got all 8 data items in it. I press stat, count, 1 variable stat, and we press enter. And the stat that we're looking for here in this case is S little x, the standard deviation, okay? That will be the sample standard deviation. This will be the population, okay? We don't want that. We want this S. And that will be, how many decimal places did they say? 2 decimal places. So this 8 turns that 3 into a 4. So 2.14. Okay. 45. The figure illustrates a normal distribution for the prices paid for a particular model of a new car. The mean, okay, here's the mean, okay, and the standard deviation is 500. So that's why you see here the mean plus 500 plus another 500 that will be 2 standard deviations away. Okay, but in any case, use the 68, 95, 99.7 rule to find the percentage of buyers between here and here. Okay, that is half of 99.7%. And half of that is, notice that is half of, from here to here is half of it. So that will be 48.85%. So you type here 48.85. And that concludes. That's it. All right. So